Hello, this is Mr. Tipton, and today we are talking about measures of center. Mean and median, they're called measures of center because they describe the center of a set of data. A lot of times you hear mean, median, and mode all together, but mode is actually a measure of frequency. It's how often something occurs. Today we're just going to focus on the measures of center being mean and median. Now, you've probably run into this before, so just a little bit of review of how you calculate these things. The mean, also called the average, is the sum of the data divided by the number of data items. Okay? Something that may be a little new is to know when it's good to use the mean or the median. Your mean is going to be more useful when there are no extreme values in your data. Sometimes you may have heard those called outliers. If there are no outliers, your mean is going to give you a better description of what the center of the data actually is. The median, on the other hand, is the middle number when the data has been ordered from least to greatest. This gives us a better representation of the middle when there are extreme values, when there are those outliers in the data. Okay. On the next screen, I want to talk about those extreme values, those outliers. Here we've got two different sets of test scores. Up top we've got a 92, a 95, a 96, and 100%. And let's find the mean of those. All right, if we add all four of those test scores together, 92 plus 95 plus 96 plus 100, we get a total of 383. Oops, 383. And normally I would write it like a fraction, but I'm out of room, so I'm just going to do it this way. 383 divided by 4 gives us a mean of 95.75. Okay, the median right in the middle of 95 and 96. Again, quick review, you add 95 and 96 together and you get 191, and you find the average of those two numbers, so you divide by 2, and so our median is 95 and a half, or 95.5. That would be right in the middle of those two. Okay, so with those four test scores, 92, 95, 96, 100, we have a mean of 95.75 and a median of 95.5. Those are really close to each other. Okay. Now let's see what happens. We have almost the same numbers here, but if you notice, I have replaced the 92 with a 0. Let's look at what the 0 does to the mean and the median. Okay, bring back my calculator here, and we've got 0 plus 95 plus 96 plus 100. We only have 291 this time. Ooh. Try that again. 291. And we're still dividing by 4. Even though we didn't have anything with the 0. 0 is still in our data, and we're dividing by the number of data items. Gives us a mean of 72.75. Look what happened to the average with just 1 0. Think if these were your tests or your quizzes or one assignment that you didn't turn in. You know, you may have all these other good scores, but that 1 0 brought this grade all the way, you know, what should have been in the 90s still is all the way down to the low 70s. All right, now the median, this is still the middle. Right between 95 and 96, the median actually has not changed. So what's a better what's a better representation of these numbers? The median probably is down here because it's got that outlier, that 0. Now, mean and median were awful close on the first one, but because there aren't any outliers, the mean is your most reliable. Okay, let's look at a couple more examples involving mean and median. This one says find the mean and median. We've got numbers of people in the House of Representatives from each state. Okay, going to bring the calculator back to add those. Better move it out of the way so I can read my numbers. We've got 53 plus 27, 18, 14, 12, 27 again, 13, 16, 18, and 36. Gives us 234 divided by, looks like there's 10 different states in our data, which is going to give us an average of 23.4. And our median, we'll need to order these numbers from least to greatest. So here we go. Our lowest looks like 12, 13, 14, 16. We've got 2 18s, 2 27s, 27, 27, 36, and 53. Now what's right in the middle? We've got 1, 2, 3, 4, 5, 6, 7, 10 data items, which means the middle is right here. 5 on each side. Well, 18 and 18, that's not too tough. Our median is 18. Okay, so the mean, again, added everything up, divided by how many data items I added. Got 23.4. Median, put everything in order from least to greatest, and it's the middle value. In this case, it was 18. Okay, let's look at another set of data. So we have water usage in hundreds of gallons, the years 2010 and 2011. This says compare the means of both years. Okay, let's get that calculator back. And we have 12 and 21 and 18, 29, 44, 49, 38, and 32. Is 243. And how many numbers did we add this time? 1, 2, 3, 4, 5, 6, 7, 8. So we're going to divide by 8. Gives us a mean of, oh, I forgot it already, 30.375. 30.375. Now I'll switch over to blue for 2011. Bring the calculator back. 14 plus 20 plus 15 plus 21 plus 27 plus 30 plus 19 plus 18. 164 divided by 8 gives us 20.5. 164 divided by 8 gave us 20.5. All right, now what were we told to do? We were told to compare the means of both years. So, you know, I mean, what can you say? The average or the mean water usage was greater or higher in 2010. If we were asked to draw a conclusion or make an inference about this, we might say something like, well, maybe they used less water in 2011 because they were trying to conserve water. You know, they were going green and wanting to do their best to save the planet. So maybe that's why they used less water. That's an inference we could draw based on the data that we have. So that was comparing the means. Example 3 wants us to compare the medians of both years. So for 2010, we've got 12, got to put them in order, 18, 21, 29, 32, 38, 44, 49, and our middle is right here. 29 and 32 is 61, and 61 divided by 2, since there were two numbers that we added, is 30.5, and you can use your calculator for that, no problem. Oh, let's switch back. Our median for 2010 is 30.5. That's what's right in the middle of the data that we have. And 2011, 14, 15, 18, 19, 20, 21, 27, and 30. What's right in the middle of 19 and 20? 19 and a half. So again, we're comparing. We can say the median water usage was greater in 2010. Or I guess we could say the median water usage was less in 2011. Different ways to write it. And again, why was it less? We don't know, but we could infer that maybe they were trying to save water a year later. Maybe they were running out and they had to. We don't know. We can just do our best to infer with the information that we have. Anyway, that's a quick review of mean and median, which are measures of center. If you have any questions, please write them down, and we'll see you soon.